Let's continue. Let's talk about the generalized product rules this time. This one applies when we have 3 or more functions multiplied together. And this is for 3-function case, u, v, w. And please note that this rule is direct extension of the standard product rule. Standard product rule has 2 functions, u and v. And then we have uv plus another uv with the derivatives for the first function in first and second function in second. The same thing applies for product of 3 functions uvw. Here it is, uvw, uvw, and then another uvw, the same order. And the derivative comes in the first place, the second place, and a third place respectively. Well, did I say that I like my convention of product rule better than that of the textbook? Well, here's reason number 2. It can be generalized into the 3-function case or 4-function case rather easily. If you're interested in arbitrary form, here it is, u1, u2, u3, all the way to un. And then you're gonna get the first bunch, and a second bunch, the third bunch, and so on, and the nth bunch. And the derivative goes to the right place. First, second, and third for third, fourth for fourth, and so on, until nth for nth. How about some examples? Here they are. We have 3 functions, right? u, v, w. So the derivative will be just uvw, uvw, and then another uvw, except that the first u is going to be u prime, highlighted in blue, and the second v will be v prime, highlighted in blue, and third w is w prime, highlighted in blue. Here's another problem. Well, this looks like 4 functions multiplied together, but in reality just 3, because x times square root of x is just 3/2 power. And then the same rule applies. uvw, 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 and then this is u prime, the derivative of first function, the derivative of second function, derivative of the third function. What if we have product of 4 functions? uvwx, I don't know, that doesn't work very well. Let's say a, b, c, d, 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 and the first one, a prime, b prime, c prime, d prime, those are highlighted in blue. First function in first, second function in second, third function in third, fourth function in fourth. Same order, just added multiple times. These are the generalizations of the product rule. After the generalized product rule, you'll appreciate the brevity of this product rule here rather than some other notations. Just one more applications, and then we're going to move on to the next topic. Let's talk about the tangent function here. Here's a reminder: the derivative of the equation of the tangent line can be summarized as follows in a single formula like this, but in reality it's gonna take this kind of form. First, we have to find out y-coordinate value by plugging in. Next, find out the derivative function. Plugging in, we can find out the slope. And now that we have slope m value, y naught you found in step 1, and x naught you are already given, you're gonna get the slope point equation of your line. So how do you handle this kind of problem here using that? Let's follow the same convention, same step-by-step process. Plug in x equals to 1 to get y naught. Let's just do it. Y naught is plugging in and you get 2e. Next step, we take the derivative. This is gonna be a product rule. The derivative of first function times the second function, no change. First function times the derivative of second function. U prime v plus u v prime. Okay, and then let's move on to slope. Plug in x equals to x naught, which is 1. What we get? We have 3e. So we have everything. Slope, y coordinate value, x coordinate value. So put everything together into the slope point equation of a line. We have it. Y equals to 3e, parenthesis open, x minus 1 plus 2e. This is correct equation of the tangent line. However, in some cases you may be asked to simplify and get slope intercept equation. In that case you can obviously I skipped that part, so you can break up the parentheses and then you're gonna get minus 3e plus 2e, so eventually you're gonna get 3ex minus e as your equation of the tangent line, or slope intercept equation of the tangent line. To me, this one is just fine. This is gonna be the one that WebAssign or computer graders will require. I think this is the justification. Is it? Yes, it is. We have curve and the tangent line. Okay. How about this problem? This problem is an application of the quotient rule with tangency, and let's simply follow the same step-by-step process. Plug in to get y naught, because x naught is given as 4, so let's do it. Plug in x equals to 4, we have, 1. And then let's take the derivative. That's going to be the quotient rule. The denominator is squared, alright? U prime v minus u v prime. Okay, and then let's just plug in x equals to 1 and then do some computation. We end up with m equals to negative 3/8. We are ready to plug everything back into slope point equation of the line. Here it is. That's going to be the final answer. And of course, if you want the slope intercept equation, you can break up and then get y equals to mx plus b form. I'll leave that to you. And here's the justification by the graph here. Blue is the curve, and then purple is the the tangent line, and then negative 1/3. Okay, there it is. Okay, obviously we have quite a bit of time left, so let's move on to an application. Here in this notebook I have it in section 4, derivative rules for undetermined functions, and the first one is related to product and quotient rules. Let's talk about this one. Well, here it is. F of 2 is given as negative 3, g of 2 is 4, f prime of 2 is negative 2, and g prime of 2 is 7. Find out h prime of 2, where h of x is given as, these. Algebraic equations for f of x and g of x are not given. Therefore, you cannot actually calculate and find out h prime of x. However, applying the derivative rules, you can find out h prime of 2, because all these x values are 2. Well, the first is rather trivial, so let me show everything right away. H prime of x is, of course, 5f prime of x minus 4g prime of x, because, those are coefficient and an addition rule. So h prime of 2 is going to be 5 f prime of 2 minus 4 times g prime of 2. So all you have to do is plug in these values in right places, and then just run calculator to calculate the answer. And wait a minute, this should be minus 43. Okay. What if we have f times g? That's going to be related to the product rule. The derivative is going to be h prime is the product, so f prime g plus fg prime by the product rule. So h prime of 2 will be given by f prime of 2 g of 2 plus f of 2 g prime of 2. The final step, all you have to do is go back to this this part, and then plug in appropriate numbers in appropriate places. F prime of 2 is negative 2, g of 2 is 4, f of 2 is negative 3, g prime of 2 is 7, as we have all here, and then calculate all that. I got negative 29 if I did all the computation correctly. The next problem is going to be pretty much the same. Instead of the product rule, you'll have to apply the quotient rule, and that's the only difference here. I'll just show you everything right all together. Denominator squared, f prime g minus fg prime, here we go, and then plug in x equals to 2, all that, and all these values will just come into play, and put all those values in right place. Do some computation. I ended up getting 13 over 16. I hope this computation is correct, but that's of course the minor part. Finally, this one, a little bit of further thinking is necessary. Using the quotient rule, we can calculate the derivative as follows. The denominator squared, the numerator is g prime, and then the 1 plus f is the denominator. G times the derivative of denominator is 1 becomes 0, f becomes f prime. So this is just a quotient rule. And then what do we do? X is 2, isn't it? Alright. And then plug in all those values in right places. G prime of is 7, f of 2 is negative 3, g of 2 is negative 4, f prime of 2 is negative 2. Run all the computation and run the calculator. You get negative 3/2. Not difficult at all. Okay, still a little bit of time, so let's move on to the final example here, and it is related to the graph. And here's a graph. Actually, I took this graph from our textbook, Stewart's book, and let's define P as the product f of x times g of x, Q as quotient f of x over g of x. Let's not pay any attention to composite functions at this moment because that require 3.4 chain rule. And f and g are of course given by these two graphs. And then please note that majority of those f and g consists of the line segments. So the tangent line is the line segment itself, and that slope is easy to find. So let's answer these two questions. What is p prime of 2 and what is q prime of 7? Looks like I'll had better copy these over here so that you can see the graph and then the answer together in the same viewing window. Let's see, what is p prime of 2? P prime of x is given by f prime g plus fg prime by the product rule. After all, this was an application of the product rule, isn't it? And then p prime of 2 is f prime of 2, g of 2 plus f of 2 times g prime of 2. And then the hard part, what is f prime of 2? You have to find out from the graph. X equals to 2. Right here, what is the slope here? Slope of the tangent line is horizontal, so f prime of 2 is 0. G of 2 is easy, that y coordinate, that's 2. F of 2 is easy, that's 3, y coordinate. And then g prime of 2, the slope of tangent line or slope of this line segment itself is 1/2. So we get this computation, and with calculator computation I'm gonna get 3/2. You can do pretty much the same thing for the quotient rule actually. Just get the quotient rule and then plug in 7, and when x equal to 7 right here, this point and that point, you have to find out the y coordinate values and then slope to answer all these and then run the computation. The detailed computation is left to the students. So we can answer the problems relating to graphs by finding out the y-coordinate and the slope of tangent line in appropriate places.